talk about some coronaviruses. I did want to point out before starting that this is a new chapter in this book. This is the first edition of the book to have any info really on coronaviruses. And obviously this is a rapidly evolving group of viruses, at least in terms of human virology. So just keep that in mind. We certainly don't know everything, but we'll give at least an overview of what we do know. We're going to start with a little bit of just brief classification, talk about some of the outbreaks of the major human coronaviruses, as well as their potential origins, mostly zoonotic. We'll go through epidemiology and clinical course of infection for those coronaviruses that have been problematic in humans in recent years. I'm going to stop the video there, and I'll pick up a second video then that will go over the replication cycle of SARS-CoV-2, as well as vaccine and other antiviral treatment efforts. All right, so coronaviruses can infect basically most animals as far as we know, everything from birds to humans, lots of other species in between. We'll see a few of those in the course of this lecture. These are all enveloped, positive sense, single-stranded RNA viruses. We're in the family Coronaviridae here, subfamily Orthocoronavirinae, and then we have alpha and beta coronavirus genuses here, both of which contain a number of species and subspecies that are capable of infecting humans. You see the key ones we're going to talk about listed here. And there are 4 on that list. Let me go back. It's basically these 2 in the alpha and these first 2 in the beta here that just cause seasonal cold-like illnesses, as well as sometimes causing croup in infants and young children. We'll come back around to that. But then there's the 3 that we probably tend to think about, which is MERS, SARS-CoV-1, and SARS-CoV-2 that can cause much more severe respiratory disease and can be potentially life-threatening in humans. So that's MERS here and SARS-CoV-1 and 2 down here. And we're going to get into this, but the majority of these, at least these last 3 for sure, are believed to have, primarily started as zoonotic diseases that were then transmitted to humans. Which takes us into some of these key outbreaks and their potential origins. So we'll kind of go through the big 3 that I mentioned that can cause more serious human disease chronologically. So we're going to start with SARS-CoV-1. It was originally just referred to as SARS in the general media. But we had, this kind of first came on the scene in November 2002. There was a very severe viral pneumonia outbreak in a specific province in China. First started to pop up in people working in food service industry in that area, and then as they sought out medical attention, spread into healthcare workers, and kind of grew from there. From there into hospitality industry, etc. So unfortunately, we're all familiar with how these things can spread. They did have very tight containment efforts because, as we'll see, this was pretty serious virus, had almost a 10% fatality rate. So by about July 2003, so a good, 7 or 8 months later, they had been able to contain and stop the spread. But this wasn't before we had over 8,000 cases and 700 deaths attributed to SARS-CoV-1. In terms of where this came from, they had tested a number of live animals that were for sale in the retail market in this part of China, and a fair number of those were testing positive for a virus that at least had very high homology, so 99+% homology to the human SARS-CoV-1 virus. And the animals we're primarily talking about here are palm civets, which you see pictured here, and raccoon dogs, which I don't have a picture of, but these are exotic animals that we obviously don't have in the United States. So 3 of these cases, I mentioned this broke out in the food service industry, were traced back to a restaurant that did have live palm civets in-house and that had tested positive for that particular virus. So that seems like a pretty clear source of that particular virus. Although later studies found Chinese horseshoe bats carrying the virus, and it's likely that those bats were probably the initial reservoir infecting the palm civets that would have been exposed to, bat guano or, something like that may have had virus in it. So they were probably an intermediate host that then transferred it to humans. All right, then the second on the list is MERS, M-E-R-S. Stands for Middle East Respiratory Syndrome coronavirus. And this outbreak began in June 2012. There was a 60-year-old man from Saudi Arabia, went to the hospital with fever, cough, shortness of breath, and ended up dying just a short 11 days later. They tested some of his mucus from his lower airways and found coronavirus DNA sequences. And at the time, they were just considering this to be a novel beta coronavirus. Since became known as MERS. This one is very sporadic, so it hasn't caused any, big epidemics with human-to-human spread. But particularly in Saudi Arabia, there have been kind of a slow but steady number of cases. So as of a few years ago, June 2021, there had overall been about 2,500 confirmed cases. But this is, in humans, a much more severe virus, so about a 35% fatality rate. So definitely not one that you want to get. It's pretty clear that the zoonotic reservoir is the dromedaries, so camels essentially. They estimate about 80% of adult dromedaries in the Middle East, Asia, and Africa, for that matter, have antibody against MERS. So it seems like it's a pretty common virus in these animals, and I think it's probably been circulating in that host or those hosts for many years. And then that leaves us with SARS-CoV-2 or COVID-19 that we all have personal experience with. And, we've lived through this, so I don't want to belabor some of this information, but I think it's still useful to review. So, of course, we saw the first cases in December 2019 in Wuhan province in China. Started getting local spread, which then quickly became global spread, and found this to be a novel SARS coronavirus named CoV-2. And again, as we're familiar with, we think this really got a foothold due to repeated super spreader events. So conferences, people just being anywhere around lots of other people, not really understanding the potential severity or implications of spreading this virus around, really let it travel far and wide. So in the US, we started to get some of the shelter at home and face mask mandates in March 2020, as the virus was basically quickly spreading across the entire United States. So just a month later, in April, we had over 1 million confirmed cases, and certainly many more that had not been diagnosed. And unfortunately, we would continue to lead global numbers really throughout the whole pandemic. So here's a graph showing confirmed cases in the thousands in blue, and then daily COVID deaths in the thousands in red. And you can see 2 different axes here. over time. So starting in February, March 2020, up through middle of 2021. And you can see that first wave, right? We were getting many more deaths than confirmed cases, meaning people were maybe dying without having a positive test. And remember, this was before we had any really good treatments, or for that matter, really knew what was going on. So we definitely saw a rapid peak in deaths there. As things started to abate, restrictions were lifted, people, took off the masks and were gathering again, and we see a second peak, and then we got a third big mountainous peak here at the end of 2020, which was undoubtedly due to all the holiday get-togethers and family wanting to be together around that time of year. So I think this illustrates a couple of things. Certainly it shows that some of these restrictions were reducing transmission and deaths, and I think it also shows that we are pretty incapable of, completely restricting the spread of a virus that's easily transmitted, because there's just, no real will, maybe I should say, to stay away from other people. So the book takes the position that zoonotic transmission, was the most likely source of the SARS-CoV-2 responsible for the outbreak. I did just want to point out, there is some information out there regarding a research lab in that same part of China that was experimenting with some of these bat viruses. So it's possible virus may also have infected workers there and gotten out, but regardless, the initial source, whether it was from a food market, as we'll discuss, or from a lab, was certainly coming from bats, probably initially. So they have pretty good data showing more than half of all the cases that were initially reported in Wuhan in December, at the very beginning of the pandemic, could be directly traced back to some of these markets that were selling live animals in the area. So that seems pretty clear. At least half or more of these cases were probably coming from interactions with infected animals in these market settings. And it can unfortunately infect quite a wide range of mammalian species. You can see some of those listed here. You see mink on the list. Not that people are coming into a lot of contact with mink, but they can transmit mink to mink and then back to humans. So they seem to be pretty capable spreaders for whatever reason. Again, horseshoe bats that I mentioned earlier, very high percentage of those in this part of China have sequences that are very highly identical to SARS-CoV-2. So we think most likely this was coming from an animal, certainly not engineered in a lab, although there may have been some leakage out of a research lab as part of this inoculum as well. All right, so then let's go through some basic epidemiology and clinical course of infection for all these coronaviruses. And I mentioned we had 4 listed here, right, that would cause, seasonal cold-like symptoms. So basic, mildish upper respiratory tract disease. Although I think these have, at least a couple of these have also been attributed as the major cause of croup in children. If you're not familiar with that, it's again, upper respiratory infection, but you get this very distinctive sort of like barking cough, almost sounds like a seal barking. I remember very clearly my sister had this when she was probably 2 or 3, and I was a couple of years older than her. But I remember, the sound of her cough, and then, at least at that time, she had to be hospitalized to try to prevent spread, and she was in sort of a crib in the hospital that had like a plastic kind of bubble dome around it, I guess, to really try to keep her contained, keep the virus contained. I don't know if that's still what they do or not, but it's certainly stuck in my head. So in some instances, you can get life-threatening pneumonias associated with some of these coronaviruses, but that's going to be primarily just in infants or people that are very young, very old, immunocompromised. All right, so then for the more serious coronaviruses, we get a very similar clinical course of infection, just, I guess, varying in terms of severity. And of course, as we're aware, older individuals or those with specific underlying conditions are going to be much more susceptible. But you can see a little table down here for those big three, kind of in order of severity from worse to more mild, with incubation period, which is pretty similar for all three, fatality rates, which are not all that similar, and then time to death as well. As we know, SARS-CoV-2 in particular is spread primarily through inhaling some of those infectious respiratory droplets, aerosolized particles, right? It's a respiratory virus. We know the virus attaches to the ACE2 receptor, which stands for angiotensin converting enzyme 2, and we know that protein is expressed in quite a few different cell types through the upper respiratory tract, as well as in neurons, glial cells, also cells in the testes and the pancreas. So for sure it's going to be very good at infecting those cells that are coming into initial contact with those respiratory droplets. Got an average incubation period of 4 to 5 days. The vast majority, 97+%, that have some symptomatic disease are going to show signs within the first 12 days of infection, although there can be some variety there, person to person and variant to variant. And we get the symptoms that we've almost all certainly experienced. Some of these you would tend to only get in a more aggressive infection, shortness of breath. These two maybe not associated with severity, but loss of smell and taste, kind of unique compared to some other upper respiratory viruses. And this has been documented quite well in the media, but there's a much higher rate of myocarditis, right? Basically inflammation of the heart muscle in people that have been infected with SARS-CoV-2. So that's certainly a potentially worrying symptom as well. If you are going to progress into more severe disease, you'll usually start to see things ramp up about 7 to 10 days after the initial symptoms appear. And of course, in those more serious cases, you're going to get the virus actually damaging lung cells. You're going to get production, or in some cases overproduction, of inflammatory cytokines that can cause the lungs to start filling up with fluid and immune cells. And about 81% of COVID-19 patients are going to have mild to moderate illness, maybe a mild pneumonia, but usually not something that's going to require hospitalization. Excuse me. If things are going to get more serious, we saw most of the ICU admissions about 8 to 12 days after the initial symptoms started. So only about 14% of COVID-19 patients were progressing to severe illness, which would include, low blood oxygen levels and the increase in inflammatory cells, etc., some of the things we just mentioned. And even smaller percentage, only about 5%, are going to progress to critical illness, which is where you're getting septic shock and real respiratory distress, much increased risk of pulmonary embolisms and strokes, right? So, this is what was killing people in the ICU, but thankfully a relatively small percentage of patients. But when everybody's getting infected, right, as we saw, those can still be very big numbers, unfortunately. And we all know, right, age and some of those pre-existing health conditions are big players. So here's some of those listed. About half of patients that were hospitalized with COVID-19 had either hypertension and or high cholesterol. About 30% had obesity and or diabetes. About 25% with heart disease and or kidney disease. And then I was interested to see anxiety listed on here as a chronic underlying health condition, about 20% of individuals there. And the book makes a point of mentioning lack of type 1 interferon. Remember, that's one of those cytokines is associated with more severe disease, which is kind of interesting given the fact that we were getting cytokine storms and kind of overproduction of some of those pro-inflammatory cytokines. You would think maybe lacking one might actually work to your advantage, but apparently not. And here's that strong correlation with age. So this is percentage of deaths attributed to COVID-19. And you can see here, trying to do a little quick math, looks like, about 90%-ish of deaths, right, were in individuals 50 and up, with kind of steady notch up with each increase in age group there. And we touched on this in one of our research articles, at least the semester I'm recording this, 2024. We do know there's some neurological effects associated with SARS-CoV-2, so about a third of those with COVID-19 had either central or peripheral nervous system issues, everything from stroke to coma, impaired consciousness, etc. And for sure, we know a couple of those less severe coronaviruses and SARS-CoV-1 have been shown to infect neurons. And I think it's safe to say the same applies for SARS-CoV-2 for COVID-19, because for sure they have demonstrated that they're finding the virus in brain tissue at autopsy. So it seems like it's getting into the neurons as well. In terms of COVID-19 spread, you are arguably most infectious, right, getting the highest amount of virus titer one day before symptoms appear, which is a little unfortunate because, of course, you may not even know you're sick at that point, probably don't know you're sick, but you're going to keep shedding for quite a while. So people with just mild to moderate symptoms, may shed for up to 10 days, and in some cases I think longer, certainly longer if you're immunocompromised, but I think even in healthy individuals they've seen some longer spread times as well. All right, so a few more numbers to throw at you here. So at the very beginning of the pandemic, we were seeing about 14% of infections were hospitalized, about 2% admitted to the ICU, and we had over a 5% mortality rate, which is not great. We quickly made some advances there, discovered putting people in a prone position, intubating can reduce the fatality rate. So got it knocked down from over 5% to just over 2% globally, under 2%, 1.6% in the U.S. So definitely a big improvement there. And you've certainly probably heard the term long COVID, technically referred to as post-COVID syndrome, but this is instances where you have symptoms occurring for months or even years after infection. And they estimate a very high percentage of those severe cases, like cases that required hospitalization, do result in post-COVID syndrome. And this can be anything from some mild headache or just feeling a little extra tired to very severe like cognitive impairment, again probably referring to ability to infect neurons and brain tissue, to severe pain and anxiety and things like that. And they've also noted an increase in autoimmune diseases in people that seems to be associated with post-COVID syndrome. All right, I will stop there and pick it up in the next video.